Okay, L'Hopital's rule, part trace. So, if I take this problem, I've got the limit as x goes to 1 of the quantity 1 over the natural log of x minus 1 over x minus 1. That's supposed to be an x. If I plug in 1, you get infinity minus infinity, more or less. That's bad. So, what do? We have to get it in the form of 0 over 0. So, I'm subtracting fractions. Let's do that. Subtract fractions. When I do the subtraction of fractions, we're going to zip, zap, zoom. Okay? We zip, we zap, we zoom. So this is the limit as x goes to 1. When I zip, 1 times x minus 1 is x minus 1. The natural log of x times 1 is minus the natural log of x, the minus sign from this minus sign, all over my zoom. X minus 1 times the natural log of x. Okay, so when I plug in 1 now, we get 0 over 0. So now we're in business. Okay? I need to then take the derivative. I have to use L'Hopital's rule. I'm going to take the derivative of the top over the derivative of the bottom. So this becomes the limit of x goes to 1. The derivative of x is 1. The derivative of minus 1 is 0. The derivative of the natural log of x is 1 over x. All over. Product rule now, the derivative of x minus 1 is 1, so that's the natural log of x, plus x minus 1 times the derivative of the natural log of x, 1 over x. And now if I plug 1 in, what happens? We get 0 over 0. Oh crap, what do? Hey, guess what? This is a limit that's in indeterminate form. Hey, I did L'Hopital's rule once. There's no rule saying you can't do it again. In fact, sometimes, guys, you might want to do it several times over. So, L'Hopital's rule one more time. This gives us the limit as x goes to 1. The derivative of negative 1 over x is 1 over x squared. Okay? It's positive because the negative 1 cancels with that minus sign. So you have 1 over x squared. The derivative of the natural log of x is 1 over x plus power rule. 1 over x plus x minus 1 times negative 1 over x squared. If I plug in 1, we get 1 in the numerator. We get 1 plus 0, so that's 2 in the denominator. That, guys, is the answer, 1/2. So we just mentioned, so let me view, zoom out there so you can see the whole thing. The moral of the story here is that sometimes you want to do L'Hopital's rule more than once, and that's okay. That's perfectly all right. So don't feel queasy about doing that. You're more than welcome to take L'Hopital's rule as often as you want, as long as you have an indeterminate form. So with that said, let's do a silly example just so you get the idea. View, zoom, 150. If I take the limit as x goes to infinity of x to the 4th over x to the 5th. This is a silly example because we can just use Coach Bruce laws to answer this. Coach Bruce law says the limit, as you take any limit as x goes to infinity, you're able to use Coach Bruce laws. The power, the degree in the denominator is bigger than the degree in the numerator, so this is going to go to 0. If it was vice versa, it would go to infinity. If they were the same degree, they'd be the coefficients, which in this case would be 1. But the degree in the denominator is bigger, so, what did I just do? So because of that, we know it's 0, right? The answer is 0 by Coach Bruce law. But suppose we forgot about Coach Bruce laws, we can do L'Hopital's rule. Because if I plug in infinity, you get infinity over infinity. And then if you have infinity over infinity, I guess I haven't talked about this, you can use L'Hopital's rule right away. You don't have to have 0 over 0. But you need 0 over 0 or infinity over infinity. There has to be a quotient for it to work. So let's do L'Hopital's rule. You get the limit as x goes to infinity of 4x cubed over 5x to the 4th. L'Hopital's rule again. Limit as x goes to infinity of 12x squared over 20x cubed. L'Hopital's rule again. Limit as x goes to infinity of 24x all over 60x squared. L'Hopital's rule one more time. 24 all over 120x. Plug in x, plug in infinity for x. That is clearly 0. Alright, that's a whole lot of work for not a whole lot of payoff. I mean, you just use Coach Bruce laws a lot faster. But the point was, I used L'Hopital's rule once, twice, 3 times, 4 times, and you get the same answer, right? It's perfectly legal, no problems at all. Okay, so that's L'Hopital's rule. I'm going to have homework. Your substitute teacher will tell you what the homework assignment is, and so you can start working on that for the remainder of class, please. Please work hard. I know you will. I have faith that you will, and if not, the sub should tell me about it, and I can make the test that much harder for all of you. But focus. Finish the week strong by doing your homework, and I'll end with a trick. So we talked about 0 over 0, indeterminate form, confusing things. So I've got a couple of things like that. So this trick we'll call infinity. All right. So I take a ball like this. So hey, this is columns, by the way. Very easy. Here we go. See the infinite sign? Very exciting. See, there's with one hand. All right, this is orbits. There's my 0. Hey, 0. This is called the yo-yo. All right, so I'm doing lots of tricks with this ball right here. So watch carefully, please. Watch this ball right here, indeterminate form. This is the trick I'm going to call indeterminate. Oh, just kidding. Okay, that's not part of the trick. Indeterminate form. Here we go. Okay, 0. Yo-yo. Okay, there it is. Whoa. 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 You see it? One more time. Have a good weekend, guys. See you on Monday.